So I want to talk about extending Ruby by harnessing other languages in a slightly unconventional way. And basically this stems from the question, let me just turn my thingy on. What if Ruby doesn't do everything well? And you know it doesn't do everything well. It's awesome, but what if there's something you find that it doesn't do well, but you want to use Ruby anyway? And to kind of justify this question, I have to quickly tell you a story of how we came about this. Basically, we started as a startup like so many other people in the Ruby world. There was a challenge, and in our case, it was to bring meaningful insight and intelligence to market research. And that asterisk, please don't make jokes about market research intelligence. We had to do this in 2 weeks. It was one of those things where we had a series of milestones we had to hit and keep hitting them. So given those constraints, the obvious choice was Ruby. Ruby is a fantastically productive language for getting going really quickly. And our minimum viable product was done in Rails. And there was so much stuff that came for free out of the box. You know, we had devise, can, paperclip, etc. And I don't regret choosing Ruby at all. I think it actually wasn't possible for us to have done it any other way. We wouldn't have hit those deadlines. So there's all that stuff that Rails is really good at and Ruby is good at. But what about our specific business problem, the actual requirement? And basically, we kind of ended up needing numerical Ruby. So the type of problem or the types of requirements that we needed to satisfy, we're dealing with data that has a very high degree of dimensionality. And just give you a brief idea of how this looks. Just picture tables going down a very, very long way and going across a very, very long way and trying to work out which answers in which columns affect which answers in other columns and trying to work out the one that has the biggest spread across 40 gigabytes per data set. The other characteristic is the data is loosely structured. There's a lot of survey data, stuff coming in from all sorts of sources. It's really hard to make it work with SQL databases and BI cubes because you have to do so much cleaning and structuring before you can do anything. And then finally, interrogate anything, buy anything. And the main thing about this is that it really blows away your opportunity to cache intelligently and pretend that you have a super fast language at your disposal. So we've got a short talk, so well, short amount of time. Long story short, we did try in Ruby. We tried to defer solving this problem. That's a log scale, that chart. And you can see over time we kind of kept things going up exponentially better. But I've marked this complexity inflection point around about 2012. And you can also view this in another way of performance versus abstraction power versus complexity. And at some point, just the sheer amount of code that was going in to optimize highly specific code paths meant that we were spending far too much time doing far too little to get stuff to be fast. Anyway, the writing was on the wall. Some guys have pioneered this route for us, and we knew we had to do something. So hypothetically, if we weren't using Ruby for this particular thing, what else would there be? And in the longer version of this talk, I can go into detail, but these are sort of the data suspects, just some of them. R is a fantastic language with a lot of depth and feature, not so great with big data, or actually not so great to use in a general programming fashion. I missed out Scala and Haskell. I also, Haskell, I couldn't get my beard to compile, so I had to move that on. And ultimately, this picture is relevant because when we were initially looking, I didn't expect to look at Python because it is conceptually similar and potentially it's the enemy. I don't know. Well, I mean, I don't really think that, but it sort of felt like I should be thinking that. So I do need to justify that quickly. Why Python? What's good about it from a data perspective? And it's actually a really pragmatic choice for an insane idea. The size of the scientific community is huge. Something I didn't know, and maybe it's obvious to others, but it is huge. The depth of the ecosystem as a result of a lot of academics and data people contributing a heap of open source. It really is the gift that keeps on giving. In a way, it reminds me of Ruby. What Ruby is to the web, Python is to data. And there's a similar-ish attitude to usability and expressiveness first. So it's not so bad going between the two. There are differences. And then most importantly for us, performance, which sounds counterintuitive, so I have to quickly explain that. The bedrock of it all is a library called Numpy, which has been going around since '95. It's really, really extensively committed, tested, optimized array library that makes use of a concept called vectorization. And Ruby has libraries like this as well. NArray is kind of a Numpy mini clone. Vectorization is basically turning the Ruby on the left into the Ruby on the right. Can everyone see that? I'll take that silence as yes. And it is possible to speed up the thing on the right by many orders of magnitude. And the reason for that is that Ruby and Python both have to do type checking. They have to do type widening. They have to cater for monkey patching, what methods are on what specific object, and the instance and meta classes. And most dynamic languages do suffer from this. So if you make a high-level method like array.sum, you can push all that down. You can ensure your data is all one type, and you can get back to C-level speeds. And that's really that's NumPy's secret. Built on top of that, specifically for us, is Pandas, which is like a Swiss Army knife of being able to manipulate data in any way. It does. If there's something you want to do to data, Pandas will do it, and it will do it exceptionally well. A lot of it is, it's also very fast. A lot of it is written in C or Python, which is like, it's C Python. And then the final other benefit of this ecosystem from a data point of view is you get SciPy, which has just got pretty much everything mathematical. Ipython Notebooks, we'll get to that in a bit. Algebra, natural language processing, machine learning, all that stuff you get for free. So just to quickly dive into the strength of the community, and this again is just for data, not for the web or anything. I mean, these are total number of commits for Pandas and NumPy, sort of versus the equivalent in Ruby that you can use. Same goes for contributors, and same goes for issues, open and closed. And I think the issues thing is the most important thing for me. Every one of those things is something someone has run into that I don't have to worry about. So this brings us to how can I use this stuff in Ruby? Because it's stuck in Python. That's pretty inconvenient, because we heart Ruby. So basically, the problem is how can I get the flexibility of Pandas and the speed of NumPy? I want to be able to scale horizontally. That kind of just want to do that. But I want a cool Ruby API into this whole thing. I don't want to be writing stuff in C. So inspiration, active record scopes. Active record is kind of doing something similar. You've got a Ruby API that's deferred and composable, and you're actually ending up writing SQL and executing that remotely. So that's kind of the same type of thing that we wanted to do. And the great thing is, active record feels like Ruby. So to restate the problem, we want to be able to get Ruby to run Python or Python to run Ruby. It's the same. It's the other side of the same coin, and you can view this as really, you need to turn Ruby into data and turn data into Python. And you can go, well, if you can get it into data, you don't have to just limit yourself to Python. You can do anything. And for some of you who've been around a while, you've probably had someone say code is data, and it was probably someone with Lisp personality disorder. They were fine, and people told you not to touch the Lisp stuff, and then they did, and they were always talking about this thing. You can never invite them to parties again. But the key to this is, in Lisp, is S expressions. This is what we actually use to get the two to talk together. We turn Ruby into S expressions. Quickly, what are they? They're just pretty much one of the simplest ways you can represent code. We're getting to brackets, so Lispy land, you guys might all have a personality disorder after this. Basically, you got your brackets. The first thing is the function name. Everything else is an argument to that function. It's very much like an AST, but simpler. So you've got to kind of read things differently. For those of you that had one of those calculators that did things the wrong way around, then you'll be fine with this. You can see what active record might look like as well, written the other way around. And you've got nesting, and I think this is important because what I'm going to demonstrate here is this is extremely easy for us to parse as humans, because I don't know if everyone knows the term BODMAS or remembers that from school, brackets over division, multiplication, addition, subtraction, and all that stuff. We just know how this is done, but if we're trying to convert this into data that is explicit, it's explicitly obvious what's going to happen. An S expression takes all the ambiguity out of that. So converting that to an S expression, if you can imagine writing a program to consume that, it's actually the simplest program you can write to do that. Active Lisp, if it was such a thing, could be maybe adequate Lisp. I think the key thing here is just everything goes inside out and inside out. Sorry, our product's called Inside Out. And yeah, so basically what we are doing is we're turning Ruby into S expressions, which is very, very easy to do. And then we're sending those S expressions over the wire because they're just data, and we're consuming them in Python. And as long as you can consume it, you can execute Ruby pretty much in anything. So does it have limitations? Yes, but I have 6 minutes and 40 seconds left before I have to do a demo, so I'm not going to go into them. It doesn't have any limitations for our use case that we have found yet. We've been using it for a year. You do actually get added benefits over actually using Python in Python, which sounds like a load of bollocks, but it's true. You can do optimization, which is just rewriting the tree that you build up from these nested S expressions. But you can do it at a level that's API, as opposed to just syntax, which is what a compiler has to deal with. So you can optimize things based on your knowledge of that specific API, which you generally can't do. And you can optimize on both the Ruby and the Python side. Related to that, you can do automatic query sharding. Because these S expressions really turn into a sort of computation graph, if you know about the API, you can make assumptions about mutability and dependencies and what can be computed in parallel and what can't. You can target multiple backends through a common API, and this is not something we have done yet because we don't have enough time, but something like Julia is looking like it's eventually going to be awesome and will probably dethrone Python in this area. It's certainly got a lot of Python people working on it. But I don't know whether this makes sense or not, and I've been following JRuby's progress, and it would even be we could even have a JRuby backend. Because I think Charles Nutter's talk will actually potentially brush on some of the things I talk about, vectorization maybe not being necessary. I don't know if you'll brush on that or not. So enough talking. Time for a live demo. Okay, I think I'm going to need to mirror quickly. Okay, so I mentioned, sorry, our product is, well, this little bit is called Quattro for no reason. And I mentioned Ipython Notebooks. They are fantastic, and I'm not going to be able to explain why. I'm just going to have to show you. But basically, they're called, the project's been renamed to Jupyter now because it's not specific to Python. And it's putting a lot of people that don't like Python off this thing. So, okay, I need to just check readability here. So, how can people read this? Okay, let me get this full screen. Right. So for this demo, I thought I would, we deal with a lot of market research data. I thought I'd have something slightly more interesting to this group. So GitHub has a fantastic open data thing on githubarchive.org where every single event that's happened to a public repo is available, which is awesome. Unfortunately, you have to get it down day by day, which is a pain in the ass, but it is also on Google BigQuery, and I have a BigQuery query there, which basically gets the data out. And so it results in a CSV, which is what I'm going to be using down here. So, just to give you some context here, this is a notebook. This is an iRuby notebook. This stuff in here is like a Ruby REPL that's talking to a Ruby process. So I'm going to run this thing now, load this data set. And that's not just slow, it's actually because I haven't started my Python side. So the Ruby side is now waiting for the Python side to return stuff. So I'll launch that. And now I have my results. We call this a measure table, a table of measures. 644,000 rows, not that many columns. It's quite a small data set for the type of stuff that we generally want to do. And I'm just automatically rendering the top 10. Yeah, so you can see I've got the actor is the actual person, or the name of the repo that you would find in the GitHub URL. There's the language, the number of pushes in that month, and then the month. And just so you know how this works in the background is basically this object has a toIRuby method which renders HTML, and that's how it's rendering. So first thing I need to do is just check if the data makes sense. And you can see one person pushed 10,000 pushes on a CSS repo in 1 month. I don't want to look at those people because they all need to be banned from GitHub. I found someone who was using GitHub as a 1-minute heartbeat monitor. Every minute a server was committing its status to a repo. So I can get the 95th percentile, which is 37, which makes me feel better. If you're pushing more than 37 times in a month, you're working too hard. So I can get my, basically construct a predicate of Boolean vectors. And again, this is all just truncated to the first 10. And now I can remove those outliers. So I haven't actually shown you what's going on from the S expression side. I could show you the S expressions themselves in sort of Lispy code, but that's no fun. So this is a much better way to look at an S expression. So this is, if I zoom out here, this is an SVG rendering of the S expression that goes from Ruby to Python. And it shows you all of the nodes. What I've got here clean is basically constructed of operations all the way back right to the beginning where I have my constructor over here. So if you can see here's my quantile, there's my 0.95, and some of the stuff is internal. The other thing I can do is I can ask the server for the Python S expression once that's been rewritten to the Python side. And the cool thing about that is we get things like cumulative time. We can actually see how long the nodes have been taking to render and where the time is being used. So we get a fairly deep insight into what's going on the server. And we can do animation, and that's cool. And finally, the other cool thing that we can do is if I were to make a mistake here, I've got pushes and I just type in something like this and I make a mistake. This is the Ruby expression. There's no mistakes there because it doesn't get executed in Ruby. But if I look at the remote expression, zoom out, you can see this is a lot easier on a high-res monitor. You can see the exact node that failed. And this is pretty much what my talk is about enabling this. It's worked very, very well for us. I can briefly take you through how we end up using this. This is slightly less technical, and I'm basically taking, what am I doing here? I'm creating an index by language and month. I'm going to get the top languages. Bear in mind, this is only for people who do have Ruby in their repository. So Ruby is going to show up as #1. I think that's obvious, but that might be wrong. And then what I'm doing here is basically factoring in the usage of other languages by people who use Ruby. So Ruby is 100%. The next most popular language is JavaScript. That's probably, well, it could just be client-side JavaScript. Who knows if it's Node or not? It's probably a mix. No way to tell what that mix is. The first real language that's obvious is Java. So there you go. And of course our PHP refugees show up there. So I'm going to do one last thing, which is try and look at changes in time over 2014. So it's difficult to see here, but I'm effectively summing the pushes by month and language. I'll try and skip through this. and I'm just going to be executing these things. And so what I'm doing here is, this line of code here is basically saying, I want to know how much each of those has grown per month as a factor of its January, the number of pushes in January. And you can see the biggest growth was shell, which is interesting. And Java and Python, and I think Ruby being low is also like fairly obvious because I limited the query to Ruby users in the beginning. And then finally, this isn't that fast because I just hacked this together for this talk. But this isn't, I was hoping for something profound, but the one thing I can tell from this is that Java people don't like to work in the Northern Hemisphere summer. And neither do C people, but the JavaScript people, they don't care. They just carry on plying through the holidays. So, and that is basically it. I'm going to quickly go back to the talk, but don't worry, lunch is imminent. This was my backup slide. Thanks to all of the open source stuff that we rest on, and thanks to the team. We're based here and here, and yeah, most of the guys that wrote the stuff are in fact, all of the guys that wrote the stuff are in this room. And so it's an insane idea, but maybe it's not, I don't know. That's it. Yeah.
no como electo por la vida.